Okay, so we're going to talk today about Newton's first law. Newton's first law was a law that talks about the tendency of an object to continue doing what it's doing. But before we get to there, I want you to understand where all of this comes into play. We are talking today in this chapter, and mostly this year, about what's referred to as classical mechanics. Classical mechanics is the stuff that was given to us by Isaac Newton in the Principia, his famous book that summarized all of the knowledge up to that point on the understanding of how the world worked physically. His understanding was solely what he could observe with his eyes, nose, ears, mouth, skin, the five senses. We know today that there are things that are outside of the realm of what we can see, the very small, and we know there are things that are so large that we can't even perceive their size, such as the universe. And so classical mechanics is limited to our understanding of the modern world and what we can see. As we go further out into the small and the big, we have to make some modifications to these rules. And those are quantum mechanics and relativity. We are not going to be talking about those concepts now, but understand that the laws that we are talking about do break down in the world of the really small and the really large. Galileo actually gives us a preview to Newton's first law. Newton was, as I said, summarizing all the knowledge that was available to him at that point. And so when one of his most famous quotes is, "If I have seen further than other men, it's because I've stood on the shoulders of giants." Galileo was one of those giants. When Newton took a look at Galileo's work, Galileo talked about inclined planes, and Galileo said, okay, so imagine I have a ball on an inclined plane and it rolls down the inclined plane, a ramp, and then it gets to a level, keeps rolling. Okay, what happens if the inclined plane is bigger? Will it roll faster? What happens if the inclined plane is really big, vertical? It'll fall at the rate of gravity. And where he took this was to the thought of, well, if I have a shape like this, and I have a ball, a half pipe type thing, it'll roll down the incline, and it ends up at the same height that it started at. Well, if I now take that inclined plane and I put it out like this, well, the ball will roll to here. Well, if I take it and I have it all the way out to here, the ball will roll to here. Same height that it starts at as ends at. So if it never goes uphill, it stays level, the ball will roll on forever. So Galileo said that an object on a curved path would return to its original height, but if the ramp itself doesn't return to the original height, then the ball will roll on forever, and until it. And that's where he left it. Newton looked at that and said, yeah, but why? And they obviously stop at some point. Why is that? And so what Newton does is he comes up with his first law, which says if no force acts on an object, it continues in its original state of motion, that unless something exerts an external force on it, an object at rest remains at rest, and an object moving with some velocity continues at the same velocity, i.e., this is what we're so familiar with. An object in motion stays in motion, an object at rest stays at rest, unless acted on by an external force. And I say, there's a pause there that it's not on the screen, because that statement that's right here on the bottom of your screen is given to us by Galileo. Galileo says an object in motion stays in motion, an object at rest stays at rest. And then Newton comes and says, yeah, but unless what? Unless a force acts on it. Without a force, then nothing happens. This is a very technical way of saying an object in motion stays in motion. One, an object at rest stays at rest. Object at rest stays at rest. Two, unless acted on by a force. Three. So there's three parts to the rule. Now, Newton's law talks to us about external forces versus internal forces. This is a really good topic to understand. So I am right now sitting in 104 talking to you, and as I'm talking to you, I'm not moving, but inside of me, my heart's pumping, there's blood flowing, my eyes are blinking, but I'm not moving. So internal forces in this case would be something like my heart pumping and my eyes moving and my lungs moving. External forces would be if somebody came and pushed me and pushed me across the room. And so internal forces can be happening and there could be no external process occurring. So you could be sitting in a car and you could be moving around in the car, but that doesn't mean the car is moving. It isn't until the car's tires push on the road that the road pushes back. So there's an external force of the road pushing back that the object starts to move. So objects need that external force, and we need to separate external from internal. Another way of saying Newton's laws is that when there's no external forces on an object, the acceleration of the object is zero. If the object is not accelerating, no force is occurring. We're going to come back to that with Newton's second law. Now, this concept is called the law of inertia. And inertia is the tendency for an object to continue doing what it is doing. So an object at rest stays at rest because it has inertia. An object in motion stays in motion because it has inertia. Some objects will continue to stay in motion. Some objects will continue to stay at rest because of very specific properties related to them. So if I have a piece of paper and it's falling, it has inertia, but it doesn't have a lot of it because the air is able to move it. I take a bowling ball and I drop it. That bowling ball stays in motion, and because it has more of something. What does it have more of? It has more mass. The more mass you have, the more inertia you have. Mass and inertia are synonyms of each other. Inertia is mass, mass is inertia. And so what mass is, by definition, is the measure of the resistance of an object to change its motion due to force. It's a scalar quantity, so no vectors involved, no vector addition, just add it together, and it is measured in kilograms. Inertia and mass are one and the same. There are many examples of this idea of inertia, but here's one of them. The Taipei Tower is a tuned mass damper, which means that what that is an object that is up in a building. So in this case, the Taipei Tower has a very large mass. Taipei Tower is a very tall building, and it sways a little bit because of its height. And so to prevent the swaying, we put a very large mass hung up on the top of that building. And so as the building sways to the left, the inertia of the ball stays behind and prevents the object from starting to move because the ball wants to stay at rest. So as the tower sways east, the ball stays in place, and that slowly pulls it back west. And then the building sways west, the ball stays in the center and pulls it back east. And so you get this back and forth pull because the heavy mass damper wants to stay in place. This is the end of Newton's first law in terms of notes. I'm going to have some additional videos and resources for you to watch on this. But ultimately, what Newton's first law is it's a principle law that states that an object in motion stays in motion, an object at rest stays at rest unless acted on by an external force, and that what that means is that things will continue doing what they're doing. If you have any questions, let me know. Make sure you watch the other links.